in research, we can try out a lot of things. And this is really why I love research, and it is so much fun just working on a problem and testing out different approaches. But after all, once we go live with a product, it needs to work, because otherwise I get a lot of requests or maybe even annoyed calls.
Welcome to the Smarter Twins podcast. Today I'm pleased to welcome Alex Braun to the show. Alex comes with a strong background in construction informatics, where he holds his PhD. Since 2017, Alex led multiple research and IT positions in the Technical University of Munich. Alex is now the Senior Vice President of TUM for Digital Transformation and CIO. The Technical University of Munich is one of the most innovative and leading universities worldwide, with around 52,000 students and 12,000 employees. Alex, welcome to the show.
Thank you very much. Pleased to be here.
I'm glad to have you, Alex. So to kick this off, I'm really curious to share with our participants more about you, about your background, about your journey so far. So what brings you into the construction informatics since the very beginning until now? And if you can share with us more details then.
Sure, we'll do that. Yeah, so I studied civil engineering also at TUM actually, and very early on had a very huge interest in informatics itself, and so decided to focus my master's on construction informatics already. So this was one of my specialization areas. And apart from that, or actually after finishing my master's at TUM, I directly started my PhD also in the field of construction informatics, with the main focus on construction progress monitoring. So I very much tried to find ways and methods to assess the actual state of a construction site with automated measures like drones and so on. And so spend a lot of time researching about all of that in the context of building information modeling, obviously. And yeah, so this was the early times I did my PhD with, and after that I continued my work at the chair of computational modeling and simulation here at TUM. Became a group leader for our digital twinning group, and there we tried to also find new methods in the whole scope of digital twinning, and that's about it to start off.
Very nice. Thanks for the information. Really nice, interesting. If we think about that time, Alex, so digital methods, building information modeling, construction monitoring or tracking, all of those topics were very new at that time. Even now, BIM adoption is becoming more and more accepted, or we can see it more in the practical industry. But so from that time, how was your journey with that? Did you have enough data, enough models, enough information at the chair? How was your work? How was your journey? How easy was it?
Yeah, you're totally right. It was actually very, very difficult to get data in the first place. So we were trying to work with, photogrammetric measures, but also elaborating on laser scanning and other methods to assess the 3D, the 3D surroundings, the 3D elements of a construction site. And at that time, drones were already there, but they were pretty expensive and the camera quality was still pretty bad. So it wasn't really a tool that was commonly known to being used on construction sites. And this drastically changed over the time. So if I would have started my PhD now, it would have been way easier to get access to all this data, use the tools that are available right now, and we would have a much higher quality compared to the time when I started working on that.
I agree. And if we think about technology evolution since that time until today, It's a huge difference. So from computational power to the methods, the functionalities, the possibilities that are there, it's really different. Even if we look 5 years back, let's not go back more than that. Many things were not possible, which are now out of the shelf, and you can just take them, get the benefit directly out of them. So you mentioned the drones, you mentioned AI, you mentioned construction tracking, a lot of topics that are really touching a lot of things that are still until today a trend in the market, in research as well. And I believe without the research that was done before, we will never be able to already do this in an easy way today. So if you can tell us more about progress tracking, because this is something that affects productivity, affects where the cash flow is. I mean, we know well that in our industry at the moment, most projects are delayed or overruns in terms of financials. So can you tell us more about the technology possibilities? Because until today, we still don't see them much adopted in practice.
Yeah, you're right. Our approach basically starts off with us having a building information model of the actual construction site. So this is one of our prerequisites. See, we say we want the model to be represented in a 3D digital way with as much additional semantic information as possible. So it would be very beneficial to know about the materials of all elements, of course also about the as planned schedule for the construction, and any additional information in that regard would help to increase the detection accuracy when you do an assessment of the actual state. And then the overall goal is we try to assess the geometries, and we are doing that with drones, with photogrammetric measures. So we're taking a lot of pictures from different positions around the construction site. And when you have enough information, enough images from different points of view, you can reconstruct the 3D geometries out of these images and thus gain a point cloud, which would be an intermediate step. So you would reconstruct a point cloud out of these images, which represents 3D structure, of course, the 3D outer hull of an element. So you don't have any insights what's inside a building. You have the outer scope, which is also one of the downsides, actually. And nevertheless, you already get a very detailed overview over your building in the end. And this then can be compared to the as planned state of your building. And with this information, you can directly tell where in the process you are at the moment and whether or not you are delayed. So this is, of course, an approach that focuses mainly on the concreting works, on the overall hull of a building. And if you're coming into detail like the HVAC and any indoor construction works, this approach has certain limits. But again, we are seeing a lot of technological developments, like all these robot dogs and fancy new tools that also allow you to assess the actual state inside of a building, which then can be also used with exactly the same method, actually, to do exactly the same what we are currently doing from the outside.
If I look at your method, you need the data, let's say as planned. You need also data as is at the moment, which is the capturing. And this capturing piece can be from photogrammetry or maybe from other kind of laser scanning. We know a lot of advancements happening also today with many different scanners and different possibilities with mobile scanners where they can also leverage. And then your method can also be used as well on those afterwards to...
Absolutely, yes.
What's there, what's present, what's missing, and label them accordingly. Great stuff. I think this is really something that with time it will be probably adopted more in the market. I mean, we saw slow adoption of PIM, and hopefully also those methods will be much faster in terms of adoption because they really touch the investments and the delays, and they have impact on the money part of the construction project, which is sensible for everyone. Now, in this discussion, we talked about the digital representation. Is this a digital twin already? Or, we hear everyone talking about digital twins, and everyone has a digital twin before a building is built or during construction already. And you mentioned also semantics. So what is a digital twin to you?
That's a very good question. I think the whole community is arguing about this terminology, and everyone has a slightly differing idea or understanding of what exactly a digital twin should or actually covers. So, in my opinion, a digital twin is always a snapshot on a building or a construction site, generally speaking, that holds information that is relevant for a specific use case. So in my case, it would be the presence over time for certain elements which are relevant for this use case, but of course they are not covering any use case. So my digital twin would not cover a use case for, for energy calculations or whatever for structural analysis or something like that. So in my opinion, a digital twin is a representation of a construction site or a building that holds additional specific information that is relevant for your use case. And there might be many different ones.
I like that really, because if I look at your sentence, it has multiple important pillars that you mentioned. It has a representation. You mentioned a phase, which is construction. So according to you, the digital twin is more or less within the construction phase, and this is how you look at it somehow. And then also that it's representing maybe up-to-date or real-time or some context information for a specific purpose. So if we take this and move into framework out of it, I think we can replace maybe the different pieces of it. Like for example, some people might tell you digital twin is not on construction site, but maybe in the operation phase where I want to optimize energy, optimize air quality, optimize different things. Or other people even maybe consider it during design where they want to evaluate design options and also feed information from the site or from the area or the region of that place to do an informed design that can give best performance. So that's really interesting. And I think we hear it more at the market that people try to say there is like some digital representation and there is also this real-time information or some information that give context about the actual state. Well, I think this is some kind of consensus, at least, that we hear and we see in the market, which is really good. During your description, you mentioned detection a couple of times. What kind of detection, what kind of methods were you referring to? So we hear a lot about OpenAI, we hear a lot about language models. Can those even be used in this? So maybe this is the second part of the question, but first, what is detection?
Okay, yeah. So detection, to the extent we are using it, is in the first step geometric comparison. So meaning we are comparing whether the geometry we reconstructed somehow fits to an existing as planned digital representation of the same geometry. And if we have some first true positive values there and see, okay, this might be an element, it could be here based on certain thresholds, then we go deeper in detail. And for that, we also use the image data we previously acquired and then also use AI or actually computer vision methods to check whether or not in a certain area of an image we actually can identify the expected element. And with this additional information, we gain further confidence in our detection results after all. So meaning the detection represents the physical representation of the actual element in the end. And going further with your question, so as I already mentioned, we are using AI for this. We are using a trained network that helps us detect certain elements. And for this, again, the information on the material, the type of element, and so on, dramatically improves and increases the accuracy of our networks. And of course, so methods like AI can be used here. If you go further towards OpenAI, ChatGPT, and those, you could maybe argue whether it might be helpful to say, hey, ChatGPT, how many columns did you find on floor 2 or similar? Whether this is really a applicable use case or might be something you could find out in the future. Up to now, we did not do any research on that because this is a really applied work in the end. And so this was a period where our research actually ended.
It's a topic I wanted to investigate also since some time. I have actually played with this a little bit. I tried to give more images or different formats and see if things can be recognized. I would say for basic things, it works. You can find maybe some routes to go from one place to the other, but different things are still not there. So the accuracy of detecting spaces or information maybe from some reviews was at least lacking to my experience with what I tested so far. So it is there, but I hope that we will have more and more advancements coming.
Absolutely.
But this will be more challenging for research because people in research think to push the boundaries, and the boundaries are being pushed anyways. So maybe to switch gears a little bit and move it to... So since 2022, you started your current position as Senior Vice President at TUM for the transformation and also CIO, right? And how does it... I mean, it's definitely different from being in research, doing new innovative things, trying to look for the boundaries and push them, versus being part of this structured organization and really huge organization with a lot of dependencies. And how can you then transform it and move it forward in terms of processes, software, and all of those kind of, let's say, activities happening? So can you maybe give us more insights on that from your side?
Sure, yeah. Yeah, so as I'm now responsible for the digital transformation of whole TUM, it is, of course, a much, much broader field that I'm working on. So it's not only construction informatics, very limited to our digital twinning topics, which are very nice, of course, but having to address all issues in informatics, in the digitalization of TUM, this is, of course, only a very limited and minor part of it. So we are also working on improving our learning systems. We are working on getting also AI adopted into a whole TUM, make it usable for students, but also teachers, for research and so on. And after all, I'm also responsible for our whole computing infrastructure here at TUM. I need to support all our administration at TUM for digitizing their processes. So it's a much, much broader field. And also in comparison to research, in research, we can try out a lot of things. And this is really why I love research, and it is so much fun just working on a problem and testing out different approaches, evaluate whether or not they might work or not. And to a certain extent, I surely can still do that in my current position. But after all, once we go live with a product, it needs to work, because otherwise I get a lot of requests or maybe even annoyed calls when certain tools are not working, because anyone here at TUM is depending on our infrastructure being available for them to do their job. So this is definitely a huge difference in terms of research compared to the overall IT administration.
They are very interesting. I can completely relate to this because we at Nemetschek, we are also facing similar things. So once we create a feature, we push it to the market. It's not, let's say, it needs to be at the production level of accuracy of quality and usability as well. Very, very interesting. So if we think about those processes, do you at the moment also apply those for operating the facilities? Are you part of managing, let's say, the software or the processes for operating those facilities? So how many campuses? I think there are multiple campuses in different countries for TUM. I'm really curious how all of this works, if you can.
Yeah, that's actually a very, very, I would say that's our biggest department, our department for real estate management. And we currently have, well, depending how you count, we have around 450 buildings that are under our management with, well, I would say we have 4 larger campuses, the largest currently being in Garching, so a bit north of Munich, and then several others. And we even have currently some campuses on different states in Germany. So this makes it, of course, very complex to manage all of this. And this is also why this is a very huge department working on all these requirements. And I'm in very close contact with them. We have a good collaboration. They also have their own department for digitalization, only focused on their requirements. And nevertheless, we are also trying to support them from our board of management's point of view to facilitate their work and to make it more digital, more flexible, and to make them able to deal with the current challenges and requirements they are having with this much more digitized world compared to several years ago.
Very nice. So bridging this to digital twins, so I did also my studies in the Technical University of Munich, and I know how it is cutting edge and following up all the possible advancements. If we think about digital models, I think you probably have some BIM models, have some point clouds, have some things. But I don't know how far you are with that and how much you're adopting such kind of digital models.
Yeah, that's a very interesting point, because here again, research sort of joins forces with our actual work here at UM. So, of course, we have plans for all our buildings. We have also some additional companies that do facility management for certain campuses for us. So we have a lot of different parties that work together on maintaining our campuses. And so currently we do not have digital models, BIM models, or however you might call them, for all buildings. But here again, we are doing a lot of research. So we already started remodeling our inner city campus completely in 3D, and we are continuing to do that also for the other campuses. And this is work that, of course, is a huge effort and takes a lot of time and also, well, really good knowledge. And we are trying to facilitate that from our chair's point of view with our research we are doing in exactly that field. So we are trying to use our scan to BIM methods to facilitate this process and to make it more streamlined and maybe also a bit faster.
Yes, automation there is really very important, especially with those kind of tedious, I mean, more or less, you want to digitize the captured, maybe the campuses or buildings into more useful or more semantically rich models. And I think at least to have the shell and the important pieces, the important types in place is already a good start that can help a lot there. Maybe here we also say hello to our professor, Andre Bormann, where we work, all of this automation is happening in the Technical University of Munich. Yeah, so if we then, beside this, like the other kind of trending topics that I also heard TUM is pushing to achieve, which is having a sustainability roadmap. And I think this is also something that I heard quite often, that this is part of the roadmap and you're going forward. I'm not sure if you can share with us more about this as well.
Absolutely. So, our TUM sustainability strategy has several pillars, and we are trying to really cover the whole university. So not only buildings, but also computing, general approaches on traveling, and so on. So it covers really the whole breadth of the university. If we are focusing on buildings, as I think this is the most interesting part for us in this podcast here, we have a huge depth, to be honest. So we are a university that already exists for more than 150 years. So we have a lot of old buildings and a lot of buildings that need renovation, that are not on current industry standards regarding insulation, regarding the requirements for really environmental friendly building. And so there is still a lot of work to be done. And we are currently in the phase of trying to assess what we need to do. So we are trying to get a feeling and a better understanding of how much energy is consumed by each individual building, how much heat do we need, how much electricity is used, and so on, how many people are working in these buildings. And all this information needs to be combined to get a better an overall image of the actual consumption we are having. We are on a good track there, but it's still a lot of work. And apart from that, of course, we also need to improve our buildings. So we are putting photovoltaics on their roofs. So these, I would say, pretty standard measures that need to be taken. But apart from that, there is also a lot of additional work required to make our buildings more sustainable in the end.
Yeah, which brings me to the topic of aggregating data and also visibility of the data. This is something I always like to mention whenever I work on anything. Like visualize, see things, put them together, look at them, reason about them, and then see how you can optimize things. And I think you're really doing a lot of, it's not like a small organization that needs a little bit of work to be done, but it needs to have a vision and have everyone acting towards this goal. And I believe TUM is really one of the leading organizations to achieve such goals. And we look forward to see all of this accomplished and happening, and maybe completely functional digital twin of the campuses and the university. Thanks a lot, Alex. That was really very interesting insights about the life in TUM, how all of this being now pulled together, the challenges that such an organization is facing, especially having their students, employees, a lot of things happening on a daily basis. It's like a living organization that even with the student life probably doesn't stop even over the weekend. So all the luck for the journey you will have going forward. Maybe before we wrap it up, what would be an advice from your side to the different kind of organizations trying to transform their facilities and transform their processes to adopt digital methods? Like, how there are many people conservative about using AI or using technology or even changing processes. We hear this quite often where people say, it works, don't touch it. So what would be your advice, and how can you help people think of it in an easy way to transform their business?
That's a tough one. So I think you're absolutely right. You always need to try. So we always say here with any project we are starting, let's just make it 80-20. So just try to get roughly 80% covered, and the rest of the 20% we are doing when we have more time for that. So basically just getting things started is the most important thing in this regard. And if we are talking about these huge projects like we are facing with the environmental challenges we are currently facing all over the world, I think it's always the best to start as early as possible, and with even the most minor things you might consider not worth it trying. Better doing anything than doing nothing. And for us, it was already a very huge step to assess the actual the buildings we are having, to assess the data we can gather to get a better understanding on where we are bad, where we need to improve. So the first step already being assessing what we are having is already quite important. And then change more or less comes automatically if you are a responsible person, because otherwise everything would get dramatically worse.
So structuring what you have, understanding what you have, it will anyways show you a big part of the problem. I think there's a good saying that I like a lot from the PhD time, from the research time. Understanding the problem is, I think, 80% of the solution or something like this. And I think the same applies to most of the transformation things we need to apply. All right, that was fantastic. Thanks a lot, Alex. Maybe for our audience, if they would like to reach you out, are you active on social media, or how can they reach you out if they have?
Yes, I'm active on LinkedIn, so feel free to reach out to me. I'm happy to help.
All right, that was great. Then, thanks a lot, Alex. It was a great pleasure to host you, and have a good day.
Thank you too, and goodbye.
Thank you. Bye-bye.